what about this series? N equals 1 to infinity. I'll put that down my paper. So. Four n squared minus 3n plus 2 on top, 5n squared minus 7 in the denominator. All right. Another thing we haven't really discussed amongst ourselves here is that one other thing you're looking for here, a lot of times you can tell just by kind of glancing at the degree of the top and the bottom. I don't know if you noticed the ones that have been convergent have always been degree of the top is less than the degree of the bottom. You always have to have that. Here's why. Here you notice the degree of the top is equal to the degree of the bottom. And that's always something that you look at, because if you don't have if the degree of the numerator well, let's say is equal to or greater than the degree of the denominator, then that's a strong indicator for test for divergence. TFD. Because what's going to happen? Remember, what test for divergence says is if the limit of n going to as n goes to infinity of the a sub n, if that isn't equal to 0, then it's divergent, right? And so whenever you have that, that's a strong indicator that that limit is not going to be 0. Figure that out by now, right? So yeah, if I take the limit of just the a sub n here, 4n squared minus 3n plus 2, divided by 5n squared minus 7, divide top and bottom by n squared there, what I've got is 4 plus 3 over n plus 2 over n squared, 5 minus 7 over n squared. I got 4 plus 0, 0 over 5 minus 0, I got 4/5. In the test for divergence, that's a good thing, I guess you say, because it tells you something. If that's not equal to 0, that series diverges. So there's a lot. Yeah, it's just real tricky because sometimes 0 is what you want, sometimes you don't want 0 for certain tests, sometimes you don't want 1, sometimes 1's okay. So yeah, you just have to keep all those tests straight. In this case, not 0 means that series diverges. Now again, just to emphasize, if that equals 0, then the test for divergence tells you nothing. It still could go either way. So it's just, test for divergence just tells you something if that is not 0. If it is 0, it's inconclusive. All right. Yeah, one other thing, also again, keep this straight. This, all right, so that series diverges, but what about the sequence? if I just talk about the sequence, a sub n equals 4n squared minus 3n plus 2. If I just talk about that sequence without putting it in a series, that sequence converges, doesn't it? It converges to 4/5. So it's just when you put it in the context of a series that it diverges, you see. So again, you've got to keep the terminology kind of straightened out there, because the sequence converges to 4/5. But since it converges to something that's not 0, the series diverges. So anyway, some of those things we've talked about, but haven't really maybe specified it blatantly obvious out. Now, there are times when it's not as obvious, you know, the degree of the numerator is greater than or equal to the degree of the denominator. That may not be so obvious, but this one starts at 2 to infinity. So you can't use 1. You know, it's not exactly specified out that the degree is greater than or equal to, because here, but if you think about it, n, and then you got ln of n. So I've kind of taken ln, I've taken n down a little bit, haven't I? Because I'm ln, take the natural log of it. You see what I'm saying? So this is bigger than the bottom, right? When we're talking about positive integers. So again, that if we look at the test for divergence here, what I mentioned there is on this limit, the limit of a sub n, what do we got to do there? Don't forget about L'Hopital, right? Because that's infinity over infinity. We L'Hopital it. Then we have limit as n goes to infinity. Derivative is 1. Derivative is 1 over n, which that's 1 divided by 1 over n is 1 times n over 1. That's just n. That's just so again, that's not 0. So the test for divergence tells me that series would diverge. Okay. Any questions on that? I guess that was take number 7. Let's do number 8 here. Right. Make it n e to the negative n squared. Probably a couple ways we could go here with this, maybe. But one we haven't talked about yet is integral test. And so integral test, I believe we'll work on this. Remember, on integral test, just has to be decreasing. We can look at it, make sure it's decreasing. And it's positive terms, which, think about it, that is going to be positive terms. So yeah, integral test here is another one. That'll have you do. Actually, the integral test was one where P-series came out of it. I guess that's possible. Anyway, So how's the integral test work? Well, you do the integral from 1 to infinity, wherever it starts. Start it there. Change the ends over to x's. Do the integral. And if that integral converges, the series converges. If the integral diverges, it diverges. The series diverges. Yeah, so you just have to remember, can't get away from the integrals. They always pop up, don't they? But this one's fairly nice when it's U-substitution. You always want to look at that first. We let u equals negative x squared. Du would be negative 2x dx. So my dx is going to be d over negative 2x. That'll be a good one. Because then it's just negative 1/2 e to the u to u. That's just a nice little integral. It is a improper integral, so we are doing the t-limit thing. That no 2. But yeah, it's an easy integral. Okay, limit as t goes to infinity. Easy integral. Negative 1/2 e to the u. The integral is negative 1/2 e to the u. We're going 1 to t. But I need to make my substitution back in there. U was negative x squared. So what I'm talking about here is limit as t goes to infinity. Negative 1/2 e to the negative t squared minus negative 1/2 e to the negative 1. Yeah, I'd probably write that to figure out the limit here as negative 1 over 2 e to the t squared plus 1 over 2 to the e. A little easier to tell what's going on there. Yeah, so as t goes to infinity, you got e to the infinity squared, that's infinity. So you got negative 1 over infinity, that's 0. So you got the integral is 1 over 2e. What does that tell me? Well, that's just a number. The integral converges, right? Well, if the integral converges, the series converges. Our series in e to the negative n squared converges. Yeah, the integral converges, so does the series. Okay. All right. Now one other one, and then I'll be done here. Series is n squared over n cubed plus n to the 4th. Does that convert? Well, again, hopefully you're seeing a comparison there. I mean, it's not an obvious p series or geometric series, but if I compare it to a b sub n here, say, what would I do? N squared over n cubed. That'll probably work out, which is just 1 over n. That's our harmonic series, or the p series. We didn't do any p series either, but be sure you got p series figured out. But yeah, that's harmonic, so it's divergent. So b sub n diverges. We did a comparison test before. Let's let's do a comparison test again. Because the comparison test didn't work before. I think it will work here, maybe. So what I would need is, since I've got the divergent comparison, part one of the comparison would be what? I need A sub n then greater than or equal to B sub n. And A sub n is that. Oh, wait, I did that wrong, didn't I?
Do the fully.
Because
Yeah. I do have a P series. I was thinking I needed a P series. Yeah, it's in, I want to do these, right? So it is a P series. Aha. P equals 2. So that is convergent. Make a big difference. So those little things, yeah, they always get you. All right. So, yeah, use the comparison test again. Do the limit comparison, but let's try the comparison test one more time here. So I would need A sub n again less than or equal to B sub n. Since it's convergent B sub n. I would need the A sub n's less for this to work. And so A sub n is the n squared over an n cubed plus n to the fourth. Is that less than or equal to, and I'll use the B sub n for this because that'll be easier comparison. That's true, isn't it? Because I'm adding something here, and so that would be true. So the denominator is larger over here on the left, so that would be true. All right, so then part two, what do we need for part two? Comparison test. The limit of the B sub n. Is that right?
yeah.
Look at the limit of the B sub n's. And yeah, that is going to be 0. So we got part one is true, limit of the B sub n is 0. We're good to go, aren't we? Convergence. Okay. All right, now. Let me talk about this last thing. All right, so we've got this series convergence. Well, the next step, I guess, would be, well, what does it converge to? And that's what we talked about a little bit with our estimating sums and that sort of thing there. Yeah. Well, sometimes we can figure out even better than an estimate. And this is one. Remember, so let's say this equals some number. We know it equals some number, it's convergent. We call it S, okay? Well, one thing we can do is look at the limits, the limit as n goes to infinity of these partial sums. And sometimes we're able to figure out this sum that way. Not in a lot of cases, but in a few we can. Here's what we can know. All right. So this also, so what do we mean by this partial sum? Well, S1 is just the first term, So it'd be n equals 1 over 2. And then S2 would take that 1/2 and add to it the second term, which would be 4 over 8 plus 16. It's 4 over 24. I get 3/4. And then S3 would be those two terms plus the third term, which would be 9 over 27 plus 81. Turns out that's 4/5. You add those all up. Wait, I did that wrong. This one's 2/3. This one's 3/4. The next one, S4, same thing, but it's 4/5. I've done these already ahead of time. S5 is 5/6. Do you see a little pattern there? Well, if you can get that pattern, figure out what S sub n is, then we can use that in our little formula here and figure things out. You see, what would the S sub nth one be? Well, the top is just whatever n I'm on, right? Here's 5, 4, 3, 2. So the top one's just whichever n I'm on. And then the bottom is just one more, isn't it? So yeah, if I can get this little expression for S sub n, the limit as n goes to infinity, you see, is our sum. So that's going to be a fairly easy one. It's the limit as n goes to infinity of n over n plus 1, which that's an easy one. That's just 1. Yeah, 1 over 1 plus 1 over n, divide everything by n, top and bottom. So you got 1 over 1, that's 1. So what this is saying is that's our S, sum of our series. That's what this series equals. We add all those terms up. In this case, turns out it's 1. So on the rare occasion that you can find, a lot of times this S sub n is so complicated it's hard to find that out. But if you can, you got it. Okay. So just wanted to mention that. Finish off here.